I
So,
see it.
did you guys get um, 0 on one of your assignments that wasn't even due yet?
I hadn't noticed.
No. Let me
Oh.
see.
Yeah, they it was marked as 0, and I was all, what?
For what?
Well, you know,
For
Assignment.
it's probably when you're absent, when you don't do a group meeting, you get a 0.
yeah, but it wasn't even due. Like the due date was.
Oh,
Wait, let me just find it.
I don't have anything like that on mine.
It's for. Oh wait, what lesson are we on?
22.
Oh. Okay, never mind. It was for lesson 17. I probably didn't do it. I think he just put the grades in. But I was like, what? We did our. Okay.
Okay. I don't have anything on mine, but I mean, I have a couple of reasons for not meeting with you guys, but.
Mm-hmm. Okay, so let me just pull this up. Where am I?
Okay. Did anybody have any questions on the assignment?
Okay, so let's just look at for 11, do you have to, see, I don't get that. Oh, what's the equation? So you just plug those in, the negative 69.369 and the 7.4 y hat. Okay. Plus 7.4x. Okay.
Oh, for the last one?
Well, on my scatter plot, I already did the line, so I didn't do it twice. Okay, 51.
I just input the equation.
Yeah.
And then that gives you.
Yeah, that one makes sense. Okay, wait. Number 2. I don't understand why it says number 8 and number 9.
Yeah.
Number 8 is draw the graph.
Yeah, that one I think is wrong. I'm not really sure how or which ones we were supposed to be looking at, because it wouldn't be the graph. Well, I mean,
okay.
I guess it would. The answer says what it is, but I wasn't really certain what to say.
Yeah, I mean, only from looking at the answer page, right?
Yeah.
Okay, so let me see. 280. I don't get that. For the observed head length of 51 centimeters, what is the observed body length? Look in the data file to answer this.
Oh, so you go into where it lists all of the lengths that they.
Oh, the first one.
And you go and you find
51,
51 and that's the corresponding.
Good. Is the regression line you obtained in number 2? Number 2. Okay, I think they're talking about part 2. Wait, what?
For what number?
Where they say number 2 above. Where on 14, it says use the regression line which is probably number 12 is what they meant. Oh, shoot.
No,
Number
so in number 2, you're using that equation.
Y hat equals B0 plus B1 X.
Yeah, so you're just doing y hat equals, wait, what number is this
So
for?
the B, oh, from the thing. So it's,
Yeah, so it's y hat equals
thing.
negative 69.36. It's y hat equals
Which
y.
is the same as 11, right?
No, because you're putting in 51 centimeters. 11, you don't have 51. Yeah, so you're using the equation from 11, and you're putting in 51 where x is.
For the head length.
You see how it says 7 point, yeah, for the head length. So you're doing negative 69.369 plus 7.4 times 51.
Oh, the X.
Yeah.
Oh, shoot. Okay. I was like, which one is it? Okay. Negative 69.369 plus 7.4 times, oh, and then 51 equals 7.4 times 51. And 7.4. I just need a bigger workspace. Okay. Plus minus 69.369. 308.31. Yay! It's close enough. 308.31. Where's my page? Okay. Number 8 and number 9. Oh, for they're talking about really 13 and 14. Because if this starts on 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 13 and 14. So one's 343 and one is 308. Values are different because the points are not all exactly on the line of best fit. If you look at the graph, visually you can see the actual point of 51 centimeters is notably above the line. The line equation is the best estimate, but it's not the actual observed measurements. But we didn't use, oh. Okay. All right, cool. Oh, that's what it is. Because the formula and one is from the line. Okay. Oh, shoot. Okay, now I just need Derek. Because I'm all good.
Okay. They're just like, yeah. All right, Derek's not coming on. He's gonna have to come on sometime because we have to go over.
Yeah. Our last final project, right?
Yeah.
Okay, so quiz time.
Yeah.
Content. Okay. Group meeting. Okay. Math. Okay.
Okay.
Y equals 2.0 plus 1.5x. What is the y-intercept? I think it's the 2.
2.
Y-intercept. Let's just check and make sure.
Yeah, it should be 2.
Mm-hmm.
Given the linear equation, y equals 2, what is
Yeah.
this? Oh, 1.5.
Yep, 1.5.
Oh,
What is the predicted value of y when x equals 16?
Oh, good. Okay. 1.25 times.
I got
Is
one.
it 1? I got 1.
Yeah, I got 1 too.
Okay.
1.0.
Yep, just 1.
Yeah, just 1.
Okay, math. Confidence data. Did you guys watch that files? I thought it was
Video.
interesting, but I was like, what does this have to do with anything?
But did
It
I
was
get
like, okay. It was cool, but it doesn't teach us how to do the math problems. Okay,
Did you all get
make a scatter
a
plot.
hot dog check?
Confidence for the explanatory and score for the response. Okay. Let's see where we
Are you all
are.
in 6?
I'm on, 6. We have to make the scatter plot, so. Is it just, oh shoot.
Okay. That's
Just a regular scatter plot, not the line. Do we have to do something first?
no, just the simple scatter.
Okay.
But it does, we have to put the dependent variable in the, where is it?
Mm-hmm.
Independent variable is the x-axis and the dependent variable is the y.
It should look like a hot dog.
Okay, wait. I need to look at this for a second.
But it doesn't tell you which one.
Yeah. So I had
If
it
you
in my
go,
notes.
if you go to
So
section 3,
independent is X. What did you say, Mary?
if you go to section 3, it explains the 3 types of linear equations. Well,
I know, it
the
doesn't tell us which one in the question, which one's supposed to be, like it doesn't give us a question
Explanatory.
about and just telling us which one is the, I know we did this was in the
Independent confidence. Okay.
or in a different preparation assignment, and I think it was the confidence rating was, the score was dependent on the confidence rating.
Yeah, the confidence one is the independent.
Which is the y or x-axis?
Explanatory is independent, and it's x. Analyze regression linear.
Okay.
Okay, analyze regression linear. Oh. Independent is confidence.
Yeah.
And then
Okay, so
what?
yeah, I think it's a hot dog shape.
Explanatory value, oh, score. So score goes independent. I mean,
Score goes
dependent,
in.
whatever. Score is dependent and confidence is independent. And then do we have to change something else? It says,
No,
oh,
not
just click OK. And then it's in our thing. Okay. And then make the scatter plot. So then we go.
using simple linear functions.
Scatter plot. And then we put the line in. Hold on.
No, we don't put the line in yet. It'll tell us when to put the line in.
Oh, okay.
They just want the shape.
Analyze. Oh, graphs, legacy, and scatter dot. Okay. Oh, that's why you were saying X and Y, but it doesn't matter, does it?
It does. It does matter.
Oh, it does? Why?
Yeah, because if you do it the opposite way, the graph will be different. I've done it.
Oh.
I have to.
And it's different. Like if on the homework, if you
Okay.
do it differently than she has, you'll have a different graph and you have to go and switch them.
Oh.
So yeah, you have to put
Confidence
it dependent and
for X. Explanatory X is confidence. So confidence, X, score. That's it.
yeah.
And here's our graph. And hot dog, hamburger, or banana? Mine's banana. Mine's diagonal.
It doesn't look like a hot dog more because mine doesn't.
Like a diagonal hot dog? Is it supposed to be laying down? I don't understand the hot dog thing.
Well, that's what it says. A hot dog.
Hot dog is a banana. Oh, that's curved or straight.
Yeah. A banana would be curved.
Oh, yeah. It's a hot dog, yes. Okay, I'm going with hot dog. I don't know. That's funny. All right. Cool. Based on the shape, what can you say? Oh, yes. Simple, linear. Oh my gosh. I do not know.
Well, it says
Simple
that
linear regression.
conduct regression analysis to determine if there is a significant linear relationship.
Yeah. And the other two are not appropriate. Back
Where
in
does it say conduct
section 3.
regression analysis?
In section 3.
Under the manatees and power boats.
Oh. Oh. Okay. So it's, oh, I see.
Plot of data
Yeah,
in the scatter plot shows a curvilinear pattern. It is not appropriate to conduct simple linear regression. If you have a situation in your profession, oh, never mind. If the data look like a random scattering of points, we conclude that there is no linear relationship in the data. That's not that.
I don't think, yeah, it's not that.
How come it doesn't tell us about the first one?
Simple linear regression. Are you in the lesson?
Yeah.
Well, I guess if the other two are, since they're not appropriate, then it would be appropriate. I don't know.
Simple. We can use simple linear regression to model the relationship. Oh, I see. Conduct a scatter plot and visually examine the data. So it's linear, but they all say linear. Oh, not appropriate, so it's not the last one.
I think it's the first one.
So if it's the hamburger, it says linear regression is not appropriate. And if it's the banana, it says linear regression is not appropriate. Is that what you guys just said?
Yeah, but on the hot dog it says conduct regression analysis to determine if there is a significant linear relationship.
But what does that mean?
I don't know. We'll just go simple linear regression is appropriate for these data for this one, and we can, if we get it wrong, then
Then we'll change it.
we'll go back.
Okay. How many observations are in the data? Okay. 139?
I don't know. Is that what?
Huh?
Okay.
Oh. I just went into SPSS and scrolled down. It has 139.
Yeah.
I mean, that would be my guess.
Yeah. What is the Y? Oh, now we have to do the whole thing. Oh, but we have it. No, we don't have it. Now we have to do the whole thing. All right, let me find my... Okay, let's see. What is the y-intercept? Okay. Analyze regression linear.
I have 18.690.
Dependent. So the dependent is the score? I'm already confused on this. Shoot. X is independent.
Yeah, dependent is the score. So
and then the other one's confidence rate.
Goes in the first box, and then the other
Score
goes
and confidence rating. And that's it.
Mary, what did you say that you got?
18.690.
Yeah, that's what I have too.
Yeah, me too. Find my quiz again. 18.690.
That's 12.695.
Slope is, yeah, 12. What is predicted? Oh, and X is 4. Okay. Calculator. $12.695. Is it 69.466?
I got mine just said 69.47, but that could just be my phone.
Which one are you all on?
On 11. X is 4,
Oh,
so we do
yeah.
4 times 12.695 plus the...
Yeah, my phone just keeps bringing up 69.47. But we could...
I have 59.47.
What do you have, Mary?
59.47.
I mean, it's the same as yours.
Yeah, when we click in, we'll see. I don't know. It's cool. Data resulted from students evaluating their confidence for each question on a scale of 1 to 6. The value of y for these values of x, because there's a positive correlation with each largest x value. What? What?
What is the maximum predicted value of y? Oh, you have to do where you predict the values. So you have to go scroll down.
Oh, and put under confidence rating, put 6.
No, you put an X. And then
In the table?
you go all the way down to the bottom of confidence rating meaning, if that's the one that it is. And then you put an X there at the last one.
X? Why don't you put a number value?
Because we're trying to figure out what it is. And that's what it said in the lesson.
I thought in the lesson it said put in whatever it was, 74 or something. Oh my gosh. I do not know. Okay.
No, so after the last row of data, type the value. Oh, you type the value of X. So what is the value of X?
So in here, let me see. It says the highest confidence rating 6. So what's the maximum predicted value? That's what I think it is 6. The maximum that you could say they can say confidence rating is 6, right?
No, in the lesson you go through SPSS to use SPSS to predict the value of Y for any specified value of X. So I mean, where are you getting 6 from?
Just in the question, it says they had to place their confidence rating from values 1 to 6.
I still think we're supposed to use SPSS.
I'm kind of lost.
Let me
I don't see any other number. So I'm just going to try putting in 6 and see what happens. Analyze regression linear. Okay. Score, yes. Confidence, yes. Save, unstandardized. Continue, and OK. Pre-1. Oh, but see, when I did it, I never saw that pre-1.
Yeah, that's what's supposed to show up.
When I was doing the homework, I didn't see a pre-1 anywhere. I have residual statistics, coefficients, model summary, ANOVA removed. So maybe I did it wrong.
Gosh, so you have to like look through these and find the highest one.
Where's that in that? I can't remember.
Predicted value. So my maximum is 98.859. I don't know if that's it or not.
I have in the. Are you looking under residual statistics?
Yeah.
That's it.
That's weird. Mine's 94.
My last, I don't remember.
Oh, yeah, 94. What did I say?
Is that what? Oh, you said
Mine's
90. So I was like, oh, mine doesn't say that.
94.
So yeah, I have 94.859.
590. Yeah, I do too. So 94.859. I hope that's it. Oh my gosh.
Do we round it?
I think it is. What, Mary?
Do we round that or leave it as it is?
Leave it as 3 decimal points. Because
Just drop the 0. Yeah, so it only has 3 after the decimal.
How many
explanatory variables are present in simple linear
94.86.
What?
Variables. Independent variable is called explanatory variable.
Which is not affected by anything. So
1.
yeah, I mean, I'm saying 1.
Yes, I think 1 is right also, just because when you change it, it changes, right? I mean, I guess. Explanatory variables. Okay, wait, maybe it's
It's either 1 or more than 2.
Right. I think it is 1, but okay.
Yeah, I think they talk about it in the video. I can't remember.
Video totally lost me. Is the x variable, which is not affected by what happens to the other variables, y, which is affected. So the correlation between number.
So the explanatory variable would be the head length, because that's what we're using to predict.
Sorry,
And the response variable would be the body length, because that's what we're trying to predict. So is the linear regression equation is equal to 0.
Yeah, I
And
mean, I don't
sometimes
see why.
we'd interpret the y-intercept.
Let's just do 1, and then if it's wrong.
I think it's 1. I totally think it's 1.
Okay.
And
So then there's
1, 2.
And the response variable, I think, is also 1.
Yes.
I guess we'll see. I'm like second guessing.
Yeah.
Myself.
We'll totally see. Okay, last one. Company in South Dakota manufactures hard hats. They record measurements on all the hats they produce for quality control and planning. The measurements they collect lengths and major and minor axes, meaning the company wants to predict the hat size of the hat given the circumference. What is the response variable? Circumference. Okay, response variable is dependent. So the size, the circumference. Circumference doesn't change because it's the variable being predicted.
So the size.
I think it's the first one.
I think it's the third one. The size of hat because it is being used to. Oh no! Wait. Oh.
I think
But
it's
you're
the
using
first
the circumference.
Oh, I'm looking. Meaning coming out
I think it's the first one.
given the circumference. Yeah. Yeah, let's try the first one.
Okay, wait. Hold on a second. I gotta think about this. This size, if you have the circumference, so if your circumference is 15, then you get size large. Circumference is the independent, and the size is dependent. So what's the
Yeah, and the
response?
time variable is the
Response
response.
variable
So the
is size because it is the variable being predicted. Yeah, I think it's the first one.
Yeah.
Okay,
Okay.
I'm going to submit mine. I just saved everything. So let me see what we have. 100%! Oh my gosh! What?
Hey, did you put one sec. I'm just asking. On 11, did you put 69.466?
No, it's supposed to be
Yes.
59. Is it 69?
Yeah, I had 69.466.
Okay. Just because we had 47 and I'm going to put 466.
Yeah, that was
Wait
what
a
my
minute.
calculator came out with.
Wait a minute. Which one are you all talking about? 11?
11, yeah, it's 69.466 on mine. That's correct.
Yeah, we had 47, but because she says put 3 decimal points,
3
I put
decimals.
6.
Yeah, I think your calculators are set to just 2 decimals.
So
Well,
it's
no,
Maybe.
mine will do it sometimes. It's just
You have to expand it out. I don't know.
3 decimals.
Anyway,
So it's
yay.
59.470?
No, it's
No,
a 6.
it's
69.
69. Yeah. 0.466.
For some reason I have 59 on there. 69,666.
No, 69.466.
Oh, okay.
Mary, you're trying to change it every time.
Yeah, we're just
I don't know.
our answers were rounded up and Rosalie's wasn't, so I wanted to put Rosalie's because it says put 3 decimal points.
Right.
Okay. 6.
I never get the lesson fully until we do the meeting and the quiz. And then I feel like, oh, I guess we do understand it when we got some of them right.
I know. I'm the same way. I'm so happy it's almost over.
I know.
Never have to do math ever again. Well, I mean, except in real life. But
Okay, get this. On my grad plan, I have, you know how this class is called 221B?
yeah.
Now I have to take 221A. Does that seem backwards? That's weird.
That doesn't what?
I don't think I
221A.
really need to take it. I think it's wrong,
I
don't
think
you?
do. I think that's wrong because
Because how could I get into this class if I didn't have that?
yeah, that doesn't make sense. I'd email your counselor.
Okay, I'm doing it.
That doesn't make sense.
That's crazy. Yeah, totally crazy.
All right. So I guess
Okay, you guys got yours in?
Yes, I have 100.
we can text on
Cool.
Tuesday or Monday to
Yeah.
see what day is going to work best for everybody.
Okay,
Just
I'm
'cause
good
we
with
have-
that.
So I'll text everybody next week.
Awesome.
All right.
Thank you.
Yep. Bye, guys.
Bye.